Swayam Prabha. Digital India. Educated India.
Welcome to Module E, Lecture 4. In this lecture also we shall continue our discussion about intersection control and critical aspects of operation. In lecture 3, I mentioned to you about various MUTCT warrants for traffic signal control, warrants corresponding to 8-hour traffic volumes, peak hour traffic volumes, 4-hour traffic volumes, pedestrian volumes, school crossing, signal coordination requirement, crash experience, network, road network, intersection near a grade crossing, all these warrants we discussed. Then I briefly mentioned to you about Indian Roads Congress Guideline 93, 1985 and the 5 warrants which are given in IRC 93, 1985. 2 are related to minimum vehicular volume and interruption to continuous traffic, both are related to vehicle volume. Then 1 related to pedestrian volume and another related to number of accidents that or crashes that record is available, and then the last one is combination of warrants. The warrants are not getting satisfied 100%, but multiple warrants are getting satisfied to a large extent. So, IRC 93 actually includes mostly the same aspects as mentioned in MUTCT, but MUTCT has got additional aspects or additional considerations in the form of warrants. With this background, today we shall now discuss about signal controller and operational characteristics. As we are talking about traffic signals, therefore, it is important to tell you about some very basic and elementary terminologies which are extremely important, and we will keep on referring to these terms often during our discussion about signal controller and operational characteristics. First, about the cycle. Cycle is one complete sequence of all signal indications. Like if you think that the starting from red, then green, then amber, and then again going back to red, then the same sequence will continue. So, wherever you start, one complete sequence of all signal indications, that is called cycle. Now, what is cycle length? Simply the time required to complete a cycle or one complete sequence of all signal indications. I am telling something slightly different way, in a slightly different way, because we have not yet discussed about the concept of phase. But otherwise, it is same as what is written here, the amount of time required to display all phases associated with corresponding movements at an intersection before returning to the starting point or the first phase of the cycle. So, overall, in a very simple terms, that the time required to complete one cycle, that is the cycle length. In cycle, what we do? As you know, the basic objective is to do the time segregation of conflicting movements. So, suppose if you simply consider that east west and north south 2 roads are intersecting, and suppose if you consider only straight movements are allowed from all approaches. So, maybe first you allow north south movement to occur, first you allow north south movements to occur without allowing east west movements, then you stop the north south movements and you allow now east west movements to occur. So, these two are actually called then two phases, right. That means, the part of a cycle allocate to a movement or a combination of two or movements having the same having the right of way simultaneously. That means, maybe what you are doing first, you are allowing north south movements to occur simultaneously and then the east west movements to occur simultaneously, right. So, these are the two phases. And what is then interval? Interval is a period of time during which no signal indication changes. That means, you are giving some time for the north south movements. So, during that time the signal is always green for north south and red for east west. So, that is the time duration will be called as time interval. Similarly, when you are stopping north south, you are allowing east west movements to occur with green indication. That means, that green remains for some time, right. During that time the signal indications are not changing. So, that is again called an interval. So, overall cycle is a complete sequence of all signal indications. Cycle length is the time required to complete one cycle and interval is the period of time which no signal indication changes, and phase or phases are or phase is a part of cycle allocated to a movement or combination of two or three movements having the right of way simultaneously. So, with these elementary concepts of cycle, length, interval, phase, let us now go and discuss about various other aspects related to signal controllers and operational characteristics. First, type of signal controllers. Broadly, signal controllers may be classified as pre-timed and actuated according to the type of control they provide. So, broad two categorizations, one called pre-timed, another called actuated. What is pre-timed control? Pre-timed control exists or consists of a fixed sequence of phases that are displayed in repetitive order. That means, typically what it is, suppose we can go to the field, let us talk about an urban intersection. Typically, we can carry out the traffic volume studies, we can measure the traffic volumes and we can identify the morning peak hour, and during the morning peak, based on that measured traffic volume, we decide what will be my cycle length, how many phases will be there, how much green time will be given for every movement or every phases, right. And then that we do not change. That means, every day morning certain period of time we operate the signal with the same cycle length, same phasing, same green time distribution for different movements and no other change is happening. Maybe of course, this is still fixed time or pre-time control, when we may have one signal setting in the morning, another signal setting in the evening, because morning the traffic will be towards the CVD and the evening the traffic will be away from the CVD. So, for different movements the required green time will be different, but we are considering a typical work day, a typical evening peak or morning peak, and accordingly deciding the cycle length, green time, phasing, everything. And that every day, every weekday, every morning, every evening peak we are operating with that same, right, same cycle length, phasing, green time, everything same. So, that is called pre-timed signal. Now, this pre-timed operation of a pre-timed controller can be described as coordinated or non-coordinated. Of course, I have not yet discussed about the signal coordination, but very briefly when signals are closely spaced, we want to adjust the timings, green timings, in such a way that once the vehicle is discharged, a bunch of vehicle is discharged from the upstream signal and they reach to the downstream signal, the moment the bunch of vehicle is reaching to downstream signal, that green time is given for the downstream signal. The whole idea is when signals are closely spaced and the vehicles are in platoon and the platoon has not dispersed too much, because the spacing is not so high. So, at that time the vehicle should be able to pass through subsequent signals without stopping again and again. So, that is the coordination. So, the pre-time control could be with coordination if there are such closely spaced signal and the operation you want to do it in a coordinated manner, or you want to go ahead with coordinated signal system, then the operation could be coordinated, or it could be non coordinated. That means, simply as an isolated intersection it is operating, right. But what is the problem with, of course, most of the signals in India are operating like pre-timed control, but there are certain disadvantages with pre-timed control. One may be that every Monday or every day, every weekday at 10 o'clock, the traffic is exactly not same, or you fix up the signal or decide the signal setting for a period of maybe 9 to 11 o'clock or 8 to 10 o'clock, whatever may be the morning peak, 8 to 10 o'clock. But 8 to 10 o'clock, every 15 minutes or every half an hour, whatever interval you take, the traffic volume is not going to be same every day, not even every interval the traffic volume is going to be exactly same. It will not happen, okay? Because the nature of traffic is like that. You go today measure or count traffic at any location, tomorrow exactly at the same time, same weekdays, working hours you go and measure it, it may not be exactly same, right. So, it may happen that we at a typical peak, off peak, morning peak, evening peak, whatever you take, you are designing the signal for that traffic volume, but the traffic volume may not be really same during the entire period for which the fixed time signal is installed or designed. It will vary. So, we can go for actuated signals. That means, we can design the signal based on actual arrival, actual traffic demand. So, that means, we are actually sensing the traffic through detector, and accordingly we are optimizing the whole signal operation. Of course, this is one particular type of actuated control. There could be a variety of controls. Say for example, maybe a major road, the majority of the time the traffic is very heavy on that road, and a minor road is there, occasionally only traffic is coming. So, if you design it with a fixed time signal, or as I have said earlier, the pre-timed control, then you will always give some green time for the minor street. Actually, maybe many of the time there is no vehicle. So, the green is actually wastage. So, in that case, if we can do actuation for that particular to handle that particular traffic movements, then we can optimize the overall signal setting or make the operation even more efficient, right. So, in that case, detection could be in one approach, detection could be in multiple approach, a variety of actuation is possible, but always it is actually to make the system more efficient. So, green interval duration in that case is determined by the traffic demand information obtained from the detector. We know that how much green time will be there, it is not fixed, it depends on how much traffic demand we are getting, we are sensing through our detector or sensor. So, every time things may change very abruptly, things may change only some to certain extent. It all depends on what rules you are following, what kind of actuation you are doing, and all those things will determine the actual operation. And of course, the termination of an actuated phase requires a call for service from a conflicting traffic movement. When you go back, when you know that another approach, something is, a vehicle is waiting, and of course, there will be not that always you sense a vehicle and you will jump to that movement, right. You may not do that, but there will be other criteria, minimum time, maximum time, minimum how much green you want to give, maximum how much you want to go, all such kind of rules will be there. So, it is not just one type, it is not just one type, there are multiple types of actuated operations that are possible or actuated control that are possible. So, it could be fully actuated, it could be semi actuated, it could be coordinated actuated. You know what is coordination? So, coordination will be maintained, but it will still be actuated. So, first let us come to fully actuated signal. Fully actuated is applicable where all the movements we are actually sensing. That means, we have sensors or detectors and we are measuring all traffic volume from all approaches. So, implies that all phases are actuated, okay? Because since we are measuring traffic from all approaches, that means all phases are actually actuated and all intersection traffic movements are detected. Then we can have better optimization. As per the real context, we are optimizing the signal setting, right. So, that really good. Green time is allocated in accordance with information from detector. Some time maybe more traffic approaching, more traffic is approaching from one approach. So, you give more green time there. In the next cycle, maybe another approach little bit more traffic, you give more traffic there, more travel green time there. So, the green time is allocated in accordance with the information from detectors and programmed rules established in the controller for capturing and retaining the green, right. So, there are set of rules which are predefined and controller knows all those rules, and with all those rules the controller will make a decision or allocate the green time. Say for example, you may decide that okay, once I give green, I will give at least a minimum of so much green time. Okay? And you may decide once the detector has detected a vehicle, then maybe I should go back and give a green within certain time, that the delay should not be more than this much. So many ways the programmed rule are formulated, programmed or the rules are formulated. So many ways the rules are formulated. So, the cycle length, sequence of phases, green time split all may vary from cycle to cycle. Everything is flexible. As the traffic is approaching from different approaches of the signal or the intersection, accordingly as per real time detection, the signal is optimized. Some phase may be skipped sometime, some phase may be there for some time, the green time may vary, the cycle time may vary, the sequence of phase also may change sometimes, everything is flexible and optimized. So, that is fully actuated operation. Next, semi actuated operation. Typically, it is done when there is a major road and most of the times you anyhow need green to allow movement of traffic on the major roads. So, that is where the majority of green is expected to be, but there is a minor road. So, on the minor road we put sensors or detectors and that becomes the actuated phase. There could be more than one minor roads also, right, like this. So, actuated phases are used to serve minor movements placed with detectors at an intersection. So, the major movements we are not installing detectors, because by default they are to be green majority of the time. So, detection is not required there. So, the rule is that by default the major movements will be given green. It is only when your detector tells you that vehicles are waiting on the minor approaches, then only that comes from detection, then only as per the rules what you have set a priori, the green time will be given for the minor movements. So, the phases associated with the major movements are operated as non actuated, as I said, because there we do not want to use detectors, because by default the major movement should get green, otherwise also they should get green. The controller is programmed to dwell with the non actuated phases displaying green for at least a specified minimum duration. That means, it is not that the moment you detect that on a minor approach a vehicle is waiting, does not mean the automatic immediately will go and give green to the minor approach. There could be some kind of precondition like this, that once you give green to non actuated phases, you will give green at least for a minimum duration, specified minimum duration. Okay. Now, the sequence and duration of each actuated phase are determined by the traffic demand, how much actually is the demand. So, whenever you detect some vehicle, then only will give some, otherwise maybe there are two minor approaches like that. In some cycle you may not get a vehicle in one of the minor approaches. So, that minor approach green will not come, right. So, not that way not fixed, that every cycle, every minor phase or actuated phase will be given a green. It may be given a green if there is a demand and if it fits to the overall rules that you have framed earlier, otherwise no. Then coordinated actuated operation. Coordinated actuated operation, it is something interesting and it is a kind of a variation of semi actuated operation. That means, some of the or the minor approaches are actually actuated or we are doing detection there, and those are the phases which are actuated. So, they are still actuated, but the major stream traffic is not actuated, major stream, major movement is not actuated, and that major movement coordination with other signals, that is also maintained. That means, one thing is very important here, the cycle length will not be different over time, cycle length will be fixed, and within the cycle length the amount of green time, minimum green time given for this major movement, that is also fixed. Okay. So, maybe if there are, but whether or how much green time will be given to the minor, that will depend on the actuation. So, if you detect a vehicle, then maintaining the coordination along the major road, right, with all the signals which are actually coordinated on the major road traffic, then you will, that will be protected and then you will handle the minor road movements as per the actuation. So, what I have written here, it uses controller's force of setting to constrain the non coordinated phases associated with minor movements, so that the coordinated phases are served at the appropriate time during the signal cycle and progression of traffic along the major roads or for the major movements is maintained, that we do not disturb. And as I mentioned earlier, this type of control is associated with a constant cycle length, because you know that you will understand it more as I go ahead with my lectures in this module, that if you want to do coordination of signals, then all signals which are coordinated, they should have the same cycle length. So, here also the cycle length I cannot change. When the green to be given in each cycle also I cannot change, right. But the flexibility is when and whether I will give green time or how much green time I will give for the minor movements which are actually where the vehicles are detected using detection, and those are actually phases are actuated phases, correct. So, in summary, I have to say the type of operation could be pre-timed, isolated, here the cycle length is fixed, applicable where detection is not available, and isolated intersection work zones, such kind of places it is applicable. Second, pre-timed could be coordinated, again cycle length is fixed. It could be semi actuated, if it is semi actuated then signal length is not fixed. Fully actuated, of course, everything is flexible. So, no way the signal length is fixed. Coordinated actuated, again the signal cycle length is fixed, okay. And I have mentioned here where what kind of operation is suitable, just an idea, not exclusive, but just an idea. Now, let us go to the operational modes of turning movements. There are two types of turning movements, permitted movements, protected movements. Permitted right turning drivers yield to conflicting oncoming vehicles and conflicting pedestrians. So, permitted left turning drivers yield to conflicting pedestrians. The efficiency of this type depends on the availability of gaps in the conflicting streams. What I am saying? Say, it is all talking about the turning movements. So, from one approach, maybe traffic is taking right turn, that is one movement. Now, that movement is happening across the movement which is straight movement from the opposite direction, both are allowed. Some cases it is allowed where it is considered to be safe, and overall vehicle volume combination is such that it can give you an efficiency without compromising the safety. So, if it is like that, that is why I say right turning drivers yield to oncoming vehicles and also if pedestrians are crossing the conflicting pedestrians. Left turn, normally the opposing vehicle is not a problem, because opposing vehicle will come on the other lane, other direction of travel. So, here the drivers may yield to conflicting pedestrians, that conflict is possible. So, that is called permitted movement. Protected movement, where the turning movements turns are happening without any other conflicting movement. That means, when I am allowing right turn, my right turn is going smoothly, vehicle from opposite straight is not permitted there at that time, pedestrians are not also given green at that time in order to conflict with the right turning traffic. Same thing, the left is given, means for the left portion where the pedestrians were earlier crossing, now pedestrians will not cross at that time. So, that is called protected. So, protected, permitted, both are there. Now, also it could be sometimes protected permitted combinations, protected permitted movements. What is that? The protected permitted mode represents a combination of the permitted and protected mode. So, what will happen? Turning drivers have the right of way during the turn phase. Sometimes you are just maybe you are allowing the right turning traffic and it is protected, right. But other time, so you have a protected phase. So, no other conflicting movements will be allowed, but also when the straight opposing straight vehicles are allowed, maybe this right turning is also given a permitted turn. So, both are there. So, that is what I say, the turning drivers have the right of way during the turn, it is the protected phase, and turning drivers are also can also complete the turn permissively when the adjacent through movement gives green. That means, opposing movement is happening with a green, but you are still given permitted right turn. So, some vehicles may take permitted turn, some vehicles at other time may take protected phase and complete the turn. So, this mode provides for efficient turn movement service, often without causing a significant increase in the delay to other movements, but one has to see that the safety should not be compromised and only certain traffic combinations, certain scenarios, this kind of things may be accepted. Now, I am showing you here the first case, a solid arrow with a distinct arrowhead indicating through movement without turning movement. Second case, shared lane, all are protected, solid arrow means protected. From one lane all movements are happening, all are protected movement. Second case, solid arrow, all three are from the same lane. So, again shared lane, but both right and left are permitted. So, using dotted line. Third, fourth case, straight and left happening from one lane, shared lane, right happening from another lane, exclusive lane, right one, but exclusive permitted. The shared lane, left permitted. Last one, separate lane, right one, it is protected, shared movements left and straight, left is permitted. So, all different combinations are possible. Now, let us come and discuss about the signal phase sequence. Signal phase plans are generally illustrated using phase diagram and ring diagram. A phase diagram shows all movements being made in a given phase within a single block diagram, and a ring diagram shows which movements are controlled by which ring on a single controller. Right. Now, what is that? Now, these days most of the modern controllers use dual ring structure. Now, what is dual ring structure? Now, this dual ring structure allow concurrent presentation of green indication to two phases, concurrent presentation of a green indication to two phases, and this kind of controllers are called more efficient, considered more efficient. Why? Because they can adapt phase duration sequence as per the need of individual movement. Earlier time most of the controllers were not dual ring structure, not having dual ring structure, it was single ring structure. So, all the movements non-conflicting movements which were allowed in a phase are under one ring, right, and therefore, the maximum movement which will have highest volume or so will dominate the green time requirement for that phase. So, but now you have dual ring structure and which is more efficient, because such kind of controllers can adopt phase duration and sequence as per need of individual movements. So, that is why always we are showing here ring 1 and ring 2, because they are actually dual ring structure and the controllers have dual ring structure. So, if you in the right side, if you consider from every approach we are allowing all three movements, left and right are permitted, and let us consider that we are using a two phase diagram. Phase 1 as usual what we are doing, we are allowing vehicles approaching from north and approaching from south to operate, to move. They may go straight, take left or take right, just one phase. The second phase north south blocked. Vehicles which are approaching from east and west are allowed to move, again straight, left, and right are permitted turn only. So, that is the two phase. So, the ring, how the ring is getting distributed is shown here. So, in this case you have vehicles approaching from north and vehicles approaching from south, both are allowed in this phase. So, vehicles approaching from north and vehicles approaching from south are controlled by two rings, ring 1 and ring 2. Same in the second phase, the east west, the east vehicles approaching from west and vehicles approaching from east are controlled by ring 1 and ring 2 respectively. So, that is what I have shown. The phase diagram shows a phase involving two opposing through movements in one block, but each movement would be separately shown in the ring diagram. That is what I am saying. Left and right, east and west approach vehicles which are approaching from east and west are shown separately in ring 1 and ring 2. Similarly, vehicles approaching from north and south in phase A is again shown differently in ring 1 and ring 2 respectively. So, that is what we are saying. Now, if you see here also again I have given you an example that here let us say that we are operating this intersection with 4 phase, right. As shown here, you can understand a protected right turn, then straight and left in phase 2 like this. You can follow the arrowheads and understand. Phase 3 approach vehicle same like phase 1, phase A1. Phase 3 the vehicles which are approaching from east side, right, and the phase B is like north south movements are allowed. So, if you put it in the ring diagram, then this is the phase which has got two movements, one is right, another is straight and shared left. So, right in ring 1, straight and shared left ring 2, but straight and shared left continue also in phase 2. So, the ring diagram it is not a separate one. So, you save actually the lost time. I will discuss it later further. That is what is the advantage also. Now, phase 3 again ring 1, the phase 2 ring 1 will continue, but ring 2 has to change because now you are allowing the protected right turn. So, that is what has come, and then in phase B you have one ring for northbound movement, another ring for the southbound movement. So, another example here also where you can see here the it is a 3 phase operation, phase A, phase B, phase C. Phase A both right turns, protected right turns you are using, and then east west, straight and left, permitted left, and then north south, straight left right, and left or right turning are permitted. So, obviously, the corresponding ring diagrams are shown here. Now, there is also a concept of movement groups and lane groups. Now, a turning movement served by one or more exclusive lane and no shared lane should be designed for as a movement group, and any lanes not assigned to a group by the previous rule shall be combined into one movement group. So, you can see here the turning movement served by one or more exclusive lane. So, the left turning is an exclusive lane here. So, exclusive left turning movement group. Then any lane not assigned by the previous rule should be combined into a movement group. Here you can say right where is not exclusive, it is from shared lane. So, through and right movement groups are formed together as one movement group. Now, coming to lane group, exclusive turn lane should be designated as a separate lane group, and any shared lane should be designated as a separate lane group, and any lanes that are not exclusive right turn lanes or shared lanes should be combined into one lane group. So, here the concept is very important. So, here you can say this is an exclusive left turn. So, it is exclusive left turn lane group. This is in this case an exclusive right turn. So, it is an exclusive right turn lane group, and what I have said. So, exclusive turn lanes, this with this rule two lane groups are there. Shared lane in this case in this photograph is not there, but there are two straight movements. So, any lanes that are not exclusive turn lanes or shared lanes. So, therefore, another lane group we are formulating. But in this case the right turn is a shared one. So, one is exclusive left turn group, another is exclusive through lane group, and another as per this second rule of lane groups, the right turn and through shared lane group. So, another lane group. So, lane group possibilities could be exclusive left turn lane, exclusive through lane, exclusive right turn lane, then shared left turn and through turn, shared left turn and right turn, shared right turn and through, shared left, through and right. All these are possible lane groups. Here I have shown an example, with this I will close almost. So, here I have shown the movements by lane. So, this will give you even more clarity. Left, through, right, shared from one only, all three movements are happening. So, lane group wise also only one movement group and also one lane group, not different. Here lane group and movement group will not be different. Next case, one shared lane through and left, another one shared lane through and left, another exclusive right turn. So, the movement groups are also like this, straight and left one movement group and right exclusive right is one movement group. Lane group also is same. So, no way the movement group and lane groups are different in this case. But look at the third case. You have one shared lane for straight and left, another shared lane for straight and right. When you consider movement group, it is all together. You have to allow all this to happen together. Okay. So, this is one movement group, but when you come to lane group is left and straight, total one lane group, shared lane, and then the right and straight another lane group. Third one straight and left shared, then one through lane exclusive, one right turn exclusive. So, the movement group wise here two, straight and left together, right. So, first two are combined as one movement group and exclusive right turn is another movement group. When you come to lane group, these are three, left and straight, only straight and exclusive right. So, this will be three lane group. So, this gives you better clarity how the lane groups and movement groups are different and where they will be different, not that always they will be different, right. So, whenever we are talking about lane group, then the critical lane group also comes into picture. Here is a small example which shows you that suppose in phase A you have got two movement exclusive right 231 to 63. So, what is critical? The highest value, because that is to be accommodated by the signal setting. When I am giving green time, I should keep that 263 in mind. If I can handle 263, I can also be able to handle 231. So, this is the critical volume in phase A. Similarly, you can follow in phase B, the critical volume is 516. In phase C, the critical volume is 351, because you have many, one exclusive right turn 128, 283, 140 and 351, but the highest one that will dominate, right. So, 351 is the critical volume. So, overall critical volume, if we say critical volume in phase A, critical volume in phase B and critical volume in phase C. So, 1130 vehicle per hour. So, in summary what I will say, We discussed here about the signal controller, the pre-time controller and actuated controller. Also within actuated controller, it could be fully actuated, could be semi actuated, could be coordinated actuated. Then operational modes of the turning lane, it could be protected, permitted. In some special case, it could be protected, permitted both. Signal phase sequence, we discussed about the concept of phase diagram and ring diagram, and also mentioned to you about the critical Ren group and the critical values, how I can get the critical volume, right. So, thank you so much. We shall continue our discussion in the next class.